Chapter 22, Section 5, this is on earthquakes. So, we talked about seafloor spreading, and when seafloors spread, they're making the ocean bigger. The Atlantic Ocean is getting bigger. That means somewhere away from the Atlantic Ocean, plates must be hitting each other and getting smaller, since we know the Earth is not increasing in size. Where these plates are hitting, earthquakes occur. And when the stress of these plates hitting is great, the earthquakes crack the earth and create movement. When a big earthquake occurs, there are several smaller ones that happen right around that time, right after that earthquake, called aftershocks. So the big earthquake that hit Japan last month has had more than 50 earthquakes that are greater than 5.0. So have you ever had something slipping out of your hand and you let it go and you went to go grab it again and it kind of didn't hold it real right? You had to keep switching it until you could find a good spot to hold it? That's kind of the thing. The rocks are trying to hold each other, and they keep moving until they find a good spot where they can hold and not move too much. As these plates move, the stress in the crust creates two things: faults and folds. A fault is a break in the crust. And so in this picture here, you can see a fault line. And there are places on Earth, including in California, where you can see the San Andreas Fault. You can see the crack between the two sides. And you see the mountains kind of forming on one side and the highlands forming on the other side. So a fault is where the rock is broken, and this is where movement occurs. A fold, on the other hand, is where the earth bends. So one plate is pushing so much on the other plate, it's causing it to bend. This usually forms mountains, and you can see this exposed mountain here. The rock is folded down, up, down, a little bit less of an angle there. So this will also cause an earthquake, or earthquakes will cause this. When they crash into each other, they cause these folds, which creates mountains. Seismic waves. Where an earthquake occurs, like the actual location where the two rocks touch each other inside the earth, that's called the focus. If you were to take that line and draw straight up to the surface of the earth, that's the epicenter. So if an earthquake occurs, you may hear on a news report where they say a 7.0 earthquake hit in the United States. The epicenter was just north of Los Angeles, and the focus was about 500 feet below the surface, or below the epicenter. That's something they might say. When the earthquake hits, there are three types of waves. The first wave that occurs is the P wave. This is a longitudinal wave. Remember, longitude is like a spring. It compresses and refracts, and compresses and refracts. So the wave sends the earth out and back, out and back, out and back, away from the focus. The next is the S wave. This is a transverse wave, kind of like swinging a rope, a jump rope between two people. And it goes up and down, up and down, up and down. The one thing about the S wave is it doesn't travel through liquid. So it won't be able to travel through liquid magma or the outer core, which is liquid metal. The last thing is the surface wave, and this is the wave that you feel on the surface of the earth. The surface wave is what does the most damage to us here. So this here is a picture of these definitions. The focus, here in the center, this is where the earthquake actually takes place. You draw a straight line up from that to the surface of the earth. That is your epicenter. This is where the surface of the earth felt the wave first. Here is your fault. This is the crack in the earth. Your folds here create the mountains. You can see the circles. These are your waves away from the focus. Those are your P and S waves. So scientists want to determine how strong earthquakes are, so they use a seismograph. And a seismograph looks like this. It's a simple machine that's connected to the earth, And essentially it has a pen on a little arm. And when the earth shakes, that pen moves up and down. So you can see here there was a little bit of movement, then it got stronger, and then the earth really started to shake, and now it's calming down. This may be what a P wave would look like. You can see compression, refraction, compression, refraction. Here's what an S wave might look like, where you see the wave going in the motion. Geologists use now to measure, to relate earthquakes to each other, what they call a moment magnitude scale. And this measures the amount of energy released by an earthquake. So this is a seismograph. You can see here you've got time that took the wave to travel. Up here you have distance it traveled. So which wave moved slower, the S wave or the P wave? The S wave, because they went the same distance, but it took the P wave much less time. The S wave took much more time to get to that distance, so the S wave is slower. There will be a graph similar to this on your test with several questions about it. Anybody have any questions on the seismograph? Okay. A tsunami. It is created by earthquakes, volcanoes, and sometimes landslides. It's basically something that violently pushes water, creating a gigantic wave. Commonly, earthquakes that happen in water create tsunamis. So the earthquake that hit Japan last month actually occurred just off the coast of Japan. Japan would be over here on the high side. This side would be the ocean. Ocean side is going underneath. It's subducting. And it pushes the land up. The water above the land is pushed up, and it creates a wave that goes in both directions. And this is a picture of a tsunami hitting land.